Welcome to episode 15. My name is Blades, and as you can see by the screen, I've sorted out what we need. These are all the files that are missing code. I've been through them all and added a space so it picks it up on my list here as changes. So what we're going to do is we're going to do this episode on Object Loader. We'll just do them one by one. I think that will keep it simple. Models, model loaders, as you can see it's highlighted for me so I can find them easy. We'll pop you up. That's the header, isn't it? So let's get on with it. Let's have a look at this header. Now, models, model base is what load object obj model, returns. It returns the information model base. So where can we get that from? There is a place in our API now that will give us that. So if we look into our API and just have a look at this data loader a minute, what have we got here? We have a data loader which will, wherever it is here, load to VAO, and it will give us a model base. So we could actually use our data loader to get that return value, and that will then load all the data onto the graphics card at the same time. Let's do it. Let's do it. This is from the API, isn't it? So we better make sure we've got everything here. Go back to OBJ. Do we have the API with us? Well, we have model base, but we don't have the API. So let's include that. It's just a nice way of programming. As you saw on the master renderer, we can do things like creating programs within the construction of an object, and it's C++. It works beautifully for all of this kind of thing. And this is ... It'll be ... again because it has to go up to. Then we're going to the API, and we just need data loader. That's a .h, please. See if that clears. Yep, we now have data loader. So what we can do down here is we can ask the user to provide us with that data loader. So we can put in here data loader. No, we can't. It's API : data loader. There it is. We'll just call it loader. Keep it simple. So we can now add that to our load obj model. So let's do that. To the comma, please. So I've added a little bit here. Go back up to the top of here where there is that error marker now. There's an error marker on it. And just paste that in. There we go. That's all we really need to do, because we have all our information here. We now can use the data loader as loader. So let's do that. That is going to get rid of the test line. That clean stays, and that's a test line. That can come out, and it's a return value that we're actually wanting here. So it's going to be loader dot load to VAO, open brackets, and it's all the things that we put in here. So size of, size of, size of, size of. Let's just go borrow. We'll borrow them. Where's the best place to borrow them from? Oh, here. Let's try here. Yeah, here we go. Just borrow that a lot there, I think. copy that. It's alright, it'll just be a load of errors, but hey ho. We need to know what we're going to try and do, really. Let's be honest. Shift Alt, bring back to here. There we go. That's all. So as you can see, it's errored because we haven't gone. So start here, it says. So we shall. How shall we start this? Now, what we're going to do is use these lists, and we're going to convert all our data into these items here. I'll show you. It's got a few tricks in it. Mainly, what I'm going to do is I'm going to create an array. That's for the arrays. Remember, those arrays are going into OpenGL to be stored on the graphics card as arrays and buffers. So we need to produce a pointer, an address. So that's what we're going to do. Now, star indices can also be written as and indices 0. The address of the first item is also correct. How interesting, because that is also correct for a certain type of vector. Now remember, we've used vectors all over the place in here. We've got all these pushbacks of new items going into these vectors like m_faces, and they're just being thrown into memory at random. We don't know where anything is really. So we need to get it in order, in the correct order. And that's easy, because it's just a for loop. Yeah, it is that easy actually. So we'll start here. We'll do the indices first. I think that's a good idea. We need to call it something. Now I'm going to call it an array because I'm going to be using it like an array at the end. Alright, I think that's just to remind me what I'm doing here. I'm converting from vectors to arrays. So it's a vector of, if this thing will get out of the way, gluints. So that's unsigned int. Unsigned int. And I'm going to call it indices array. Indices. And I'll call it array. There we go. And that's all I need to do. Indices array. Copy. Indices. Paste. Now that's interesting. Because now what we need is the size. Oh, the size. So we are going to need an int. And we'll call it indices. Why am I doing capitals at the beginning? Don't do that, because you've decided that I didn't want to. Indices, and we'll call that size. I'll call that 1 for now, because I don't know what it is. But watch what happens. If I put indices size in there now, those first two items are correct. I'm just wondering, too few arguments in function call. Oh, what are you talking about? Arguments. 1, 2, 3, 4. 1, 2, 3, 4. What? 1, 2, 3, 4. 1, 2, 3, 4. Oh, right, yeah, because it's not counting them. Because I've still got int in front. Don't need it there. And we don't need the word float there. Now that's better. It's all lighting up now. Yeah, can we have an unsigned int there? No, we don't need it. Okay. Thank you. Yeah, lost. With the float. just get rid of the float. Okay. We're looking good. We are looking better now. As you can see, the first line is now correct. All the red squigglies are in the right places now. I'm now happier because all of those we haven't done. So the one that we have done is working, but it has not got the correct values in. So for loop I said would use. Let's do that here. What shall the for loop be? It's going to be for. I'll use an unsigned int equal I. May as well be I. I always use I. God knows why. It just looks okay. I use it I for index. Simple as. Nothing strange there. Most computer programmers do that. God knows why we do it, but we do. So I has to remain lower than the number of faces. So that's faces. That's faces dot. Is it a dot? Is it a dot? Is it a dot size? Is faces. Which way round have we done this? Ah, bless me. What do we call our faces? Underscore faces. It's just standard, so it's a dot. Right, okay, they're all just dots. That's fine. I don't know. So it's faces dot size. That's a function. Thank you. Yeah, that's okay. Okay, I'll type it in again. It's faces dot size m underscore, that's why. There we go. That should work now. Brackets are correct. Why are you not correct? Oh, you expected a semicolon. Right, okay. Fair enough. I'll leave that to you, Microsoft, to work out how colons work for for next loops. Right, so this indices array. We now have indices array. We are then going to dot push back. And we are going to push back I, and it's going to be times 3. So every third ith. You'll see what I mean. So we'll have to do this 3 times. That's a semicolon. So we're going to have to do it 3 times because there are 3 indices per. No, there's not 3 indices per, it's just 1 indice per point. So we're going to be doing 3 points at a time. We have to. We don't get a choice in that. So the next line is just going to be the same. But instead of 3, we are just going to add 1. Whoops, that was my telephone I just knocked. And then we're going to do the third one. You're just thinking to yourself, why are you doing it 3 times? Because we have 3 points. We have to record 3 points at a time to make a triangle. And if we don't, it'll all fail and be miserable. So we're doing each point of the triangle. So we're doing it all 3 times. And that is now correct, except our indices size isn't 1 anymore. Our indices size is the number of faces. Is it now? Well, yeah, it is, but it's faces dot size, and then some more. That has to be multiplied because we've done it 3 times. So what do we have to multiply it by? We will multiply it by, for the indices, there's 3 of them, we've done it 3 times. and we are going to multiply that by the fact that there are XYZs, isn't it, for each. So that's 3. And then we're going to have to add the 0th, starting at 0. So we have to add 3 for that, because that's how arrays work. They go from 0 to 1 below the number you ask. So if I put in indices array, open the square brackets 3, close square brackets, that would create an array. And you would use positions 0, 1 and 2 to store your data in, your 3 pieces of data, but it would still say it was 3. So we have to put that plus at the end, just to make sure we've got enough space for it to act like an array. Not be one, but act like an array when we do that at the end. When we send off that address, we need it to be the 0th address, and it needs to go as far as the last items, the last 3 items. You'll miss it out otherwise, because there's 0. It doesn't start at 1. Okay, right. So we have our first 3 indices, and it's doing it nicely, except our faces isn't working. Why are you not working properly? It's I am really forgetting things today. My apologies. I've got coffee here. Let's have a coffee break. It works now. But you can see how the code is working, and that is still looking for a semicolon. I don't know why. Why do you want a semicolon? That is so strange. Why do you want a semicolon there? That's wrong. Expected a semicolon. Where is it? Oh, it does, doesn't it? My bad. You know what I've forgotten to do, don't you? I++ at the end. My bad. It does help if you add 1 to it every time round. Right, we've got a proper for loop now. It's going, it's nice. So let's add the next one. This is where it starts getting a bit weird. Oh god, I'm enjoying that coffee too much, aren't I? Let's try doing the vertices. So, let's make something up here. We'll make up a vector. Off the top of my head. Floats. Floats. Yeah, they are. And we're going to call this positions array. It's down there as positions. I don't care what we call it really. Positions array. Vertices array, whatever you want to call them. You can call it what you like, whatever makes sense to you. And this is, I'll do it in here first, because then when I do the size of it, you might understand it better. So that we're going to need an int, and I'm using position size, and that's going to equal, I'll just put 1 in there for now. So that now becomes that. And that one will now be correct. That goes on there. And change that to address, please, because we want to send the address. Can you see what's happening? What we're going to do as our return value, we are going to call load to VAO to load up all our data, and that's automatically then going to return the model base, which is exactly what we asked this function to return. But you can see it's working nicely. Let's put some values on it. So, positions array. What are we going to do with this? We're actually going to do a pushback. And the value in the pushback is going to be from our vertex stuff. I can't remember how we did it. Vertices, m_vertices, and it comes out through a coordinate. Right, okay, yeah, that's fine. So it's going to be m_vertices, and we are going to need which one? Yeah. So we can treat this, it's already been set up, we can treat this like an array, m_vertices. I know it's a vector, but we can treat it like an array. So it'll be faces, I, hyphen, sorry, pointer to faces, I don't like this, faces, 0. It isn't a dot, it's still one of these. It isn't 0 either, it's 0 minus 1. Yeah, and that's just going to be x, and that should be a semicolon there. So that's the pushback. Have I done it right? No, I haven't, have I? Okay, what's wrong here? It's m_faces. Okay. And that will go to faces. I'm going to take -1, x. I've put the close bracket in the wrong place. That's the close bracket. And that takes that out. That statement is now correct. What's wrong with my pushback? Has no member pushback. Get lost. Of course you don't. There you go. You have that member, don't you? Yeah. So that's how we get the x value. Guess how we get the y value? Because remember, we need an x, y, and z here. So I'll need an x, a y. Why is there a -1? Because we're starting at 0, not 1. And z. Ooh. So I'll have that. Does that look right? Yeah, it does. Yep. 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 I'm happy. And as I said, we have to do it 3 times. I'm doing it 3 times, put it that way. So I'll copy that block. And all we have to do is the 2nd time and the 3rd time. And each time we do it, all we're doing is changing the numbers, which is these numbers here. So that's for the 1s, and that's for the 2s, and that's a full triangle then. That's why we're doing it 3 times. You need 3 points for a triangle. So that's a full triangle with the proper indices and the proper positions recorded now for that triangle. You're just using pushbacks. Hoping I'm starting to make sense now. I'm hoping that you're starting to see how it's doing it. It's doing it simply by taking the information that we have for the vertices, for the face of that vertice. We can then find out where it is by putting that little bit in, and then just taking the x value straight out of the vertices for that reference. That comes to an integer. Yeah, int. Yeah. Thank you. That's fine. That's because when we made all of these things here. So there's face. And there's faces 0, 1, 2, 3. You can see them. It all matches up. Trust me. On that one, it's a bit complicated, but it all matches up, and it simplifies out to that line. Just repeat the line. Yeah, nothing difficult going on. It's just knowing how to trick the computer into giving us that address in that format, which is the same format that you would use for an array, and we're using vectors. When it's received in load to VAO, it goes into a pointer, because that's an address. So it becomes a pointer. We're going to give that pointer to OpenGL in that function, or parts of that function, depending on what it does. Go and have a look. And OpenGL will then load that through to the graphics card. So you're taking it straight off disk, you're converting it into something that's usable, and then you're just throwing it into the graphics card. And it all gets deleted because of that little bit there. So I don't need to clean this part up like I had to with the others, because these are all member variables that are being cleaned up. These are temporary variables. These just die when you hit that bracket, and that means we preserve memory automatically. Should we do text coordinates next? Yeah, why not? Oh man. So it's going to be a standard vector. Now remember, these are different. These only have a U and a V. Still floats. The values of each item will still be a float. What do you want to call it? Texture? Textures array? Or UV array? Texture? Yeah. Texture array, we'll call it. You can see that I haven't written this. I'm making it up slightly. And there's only two. There's a U and a V. It's just, where do you find them? Let's take a look. We are going to then dot push. I'll do it properly this time. Back. Open brackets. Where will we find our texture? We will find it in our texture coordinates. There you go. There they are. But where in that texture coordinate have we stored them? We have stored them at faces m faces underscore faces I. Thank you, Muppet. Welcome to the team. And in that faces I, we need to look up within that structure that we wrote initially. We need to look up the text coords. Have we got them? Yeah, we have. There's your text coords. You see they're in there. And we are going to take the 0, -1 again. We're doing the -1 because everything's going to 0 rather than starting from 1. So we have to make sure that we get it in the correct place. Or get it from the correct place, should I say. Indexing has to go at -1. And all we're going to take from there is a U. I think we called it U. Well, there's one way of checking it, isn't it? Text coords. Go and have a look at the construction of text coords. Did we do one? Yeah, text coords float A, B, U equals A, V equals B. Yeah, we did. So that's right. And it will be M text chords, won't it? Because it's a member variable. And that should be right. Is it right? M text chords is undefined. Is it? M textures isn't there? I'll try it with M textures. Now you can tell I haven't done it. I haven't written this. That bracket's in the wrong place. Okay, come on, clear up. Thank you. So, we're correct. Just take that line. Now we only have to do this twice because there's only a U and a V. So all we do is that to a V. I think that's right. Yeah, I'm starting to like it. Yeah, I am starting to like it. So all we have to do is this twice for each X, Y, Z. So copy. You can see how this is building up nicely now into something that's very easy to do, but you just got to put the right values in. So it's now a 1, 1, 1. We'll do the 1, 1, 1, and a 2. That's it really. Text coordinates. Oversimplistic, just long lines and remember where you put things. That's all it is. Yeah, I know. We will need that here. So we'll just copy that out of the bottom one. Paste it there. Give it a 0th position within that. And I just want the address of the 0th position. Alright, position size. We can do that now, can't we? Int. This is texture. Size equals something. And it'll be in brackets, I can tell you that, whatever it equals. Thank you, Muppet. So we can now put U in that red squiggly bit. So that'll get U back out. Thank you. And we only have the normals to do. Isn't as bad as you thought, is it? Eh? Converting data. I mean, it's automatic conversions of data, but if you have to convert it in certain ways, otherwise the automatic conversions won't work. You'll get errors like types not being the same or incorrect type or whatever, and it'll just all break down and cry. I used to do this as a straightforward array, and these would be arrays with the size of, you know, put square brackets around that and you've got an array. But under C++14, that's illegal, because the only way you can start an array is by defining its size, and that size has to be defined at compilation time, not at runtime. This will give the size at runtime for the object that you are loading, and of course all objects are different sizes, so we can't put a static size in. We have to do a calculation, and that means I have to use a vector. But if we use a vector in this way, it then turns out at the end to be an array. If you do that, if you send it through like that, it's an array. So you're turning a vector into an array. And I've got all of this lot up here squiggling. Oh, that's alright, yeah. Which one are we doing? I forgot now. So texture array. Normals array. Oh, yeah, normals, plural, please. Normals array. We'll call it. So we will have an int normals size. That normals becomes normals array 0, and of course change that to the address, not the pointer. Normal size, I'll just pop over, paste, equals brackets 1 for now, until I fill that in, because that's a bit that's not going to make sense to anybody. So we are now doing that, and it's actually working. Wow, that is awesome. We better put the normals in, I think. So here we go. So it's normals array, and we are going to push back, and it's going to be m underscore normals, please. And we want a float value here. No, we don't want those brackets, thank you. And it's m underscore faces, open brackets I, pointing to 4 vertices faces. It's pointing. It's supposed to point to something. No, it's not. Almost face. It should be some kind of number. Yeah, it is. I've put that in, haven't I? Yeah, I think it's that one. Faces num of face will be your normal. Just waiting for my cat to settle down. Come on, you, out of the way. I can't see the screen, you know. I can't see the screen through you. Get out of the way. Faces normal. Let's find out what I do with the normals. I put them num of face equals face num. What did I do with the normals? And where have I shoved them? Did I do them? Vertex, vertex, vertex normal. So it's under m normals, coordinate. Coordinate. Really? Because I called the other one text coordinate, didn't I? I don't think I put it in, you know. It should be under faces a value for the normals. Have I actually not put it in? I don't think I have. Let me check my notes. Okay, lots of faces. Normals. Oh god, yes, this works differently, doesn't it? Sorry. My bad. It's face num. It is the actual number of the face that I'm after. So I want... Oops, I don't know what it's doing. Come here. So it's U2 face number. Number face, okay. And that will be -1. Yeah. It's slightly different. Because the normal's the same for each position. Because they're all facing, it's a flat plane, it's all facing the same way. So we can close that off and take the X value. Yeah, we can. Okay. I'm just thinking to myself, is this right or not? Well, yeah, it is, but it's an awkward one. Normals, there's 3 of them. There's an X, there's a Y, and there's a Z. Right, let me get my brain straight on that. I'm just going to repeat this 3 times and not change anything, aren't I? Yeah. Because it's going to be the same for every single one. So we'll just copy it to there. And copy it into that slot that I've left. There we go, that's it. So it's just that 3 times to give the normal for that position, because the normal won't change for each position because it's on a plane. So it will always be in the same direction, 90 degrees to that plane. So it just repeats itself 3 times. Yeah, I'm happy with that. Absolutely spot bob on. Now these sizes. We've got everything working now, by the way. All of these are happy and correct, so that's happy. That's a happy joy. These are all temporary and will get destroyed at the next closing bracket, which is there, that point there. So that's good. Memory, no leak. It's good. So it'll pass all the data through and then delete it all. Wow. Not a bad system. When you think it all through, it's not a bad system. It looks cumbersome and it looks like a lot of lines of code, but really, trust me, it only looks cumbersome to us humans. To the computer, that is so simple. It's untrue. When that converts to machine code, that will be just a flash in the pan. It'll repeat for every single face. Excellent. So we've got all our faces now. All in the right order and all with the correct data for each face. Now, what is the size of the data for position size? Well, it's 3, isn't it? 3 positions make 1 triangle. But each one has an X, Y, and Z. So we better put times 3 on there. So we've got 3 positions equals a triangle. I'm trying to get through this without really doing my head in. And we have a 0 on the array, so that's a multiplier. And we're also doing it 3 times here, so that's a multiplier. So that'll be a multiplier of 4 times 4. Texture. but its face's size. Hold on a minute. Times that a lot. 3 times 3. 3 times 3 of them. Plus 3 because of the 0th. Yeah, okay. So that's going to be m underscore faces. Dot size. And we're going to times that lot out, please. Yeah. That's it. Textures is different. Textures is 2, 3, 4. Yeah, okay. I may as well just copy that part out there. Pop that across the brackets. The only difference with the textures is that it's only a unit V, so I'll just reduce texture size. I'll just put the first one as a 2 instead. And that should do it. Yeah. I'm done. I'm happy. We've got everything. Wow. And again, all of that will get killed, deleted at that bracket. So it's temporary. Wow. And Shift Alt. That should be there. Thank you. And the same here. They're all tabbed in one extra for some reason. And they shouldn't be, they should be there. They're on that line. Oh, for God's sake. Turn that off again, I think. Right, that's better. Okay. Okay. Yeah, I'm okay. Actually, it is wrong. I don't care. Oh, I'm not messing around with that. It looks okay, and it will be okay. Convert data, yeah. All data is converted, cleaned up, sent off to our video card, returned what we asked for, and deleted everything. Fantastic. That is awesome. That works. That's it. Wow. What an awesome piece of programming that isn't. Oh, bless. That's awesome. Absolutely awesome. I'm really happy about that because the way I did it originally was all of these I just used arrays. So I would have put unsigned int, that, opened the thingy, and then put that calculation in. Now that worked fine under C++ 11, but under C++ 14, nah, you can't do it. They stopped us from doing it, which was a shame because I would have preferred using arrays there. It was simpler, looked a lot simpler here, but it's the same, exactly the same program. Exactly the same program, except but this one uses pushbacks instead of equal signs. That's it. If there are any problems, this is the place to look on your conversions, especially with this equation rubbish that I just magicked up out of thin air. Hopefully that will give the right values. 3 times 3 is 6, times 4 is 24, that's right. That's right. 3 times 3 is 9, plus 3 is 12, that's correct. Yeah. 12 numbers per face. 24 individual items per face, yeah. think he's right. I might go back to that and relook at it, but hey ho. If we have to change it, we have to change it. If we don't, we don't. I'm happy with the results that will give. So I'm happy there. Altered that there. Okay. So Control S. Object loader. Done the modifications. Object loader. Done the modifications. And that's... Oh. Yeah, I'll just call it object loader, why not? Updated. So that's the object loader done. Click. So that's now done. So that's episode 15 complete, and in the next episode we will go and do the camera. Now I'm only going to do probably part of the camera. I might not put the movement bits in, but I will show you some code for it. Actually, we can put it in, I don't care. EP 15 complete. Lovely. So that's it. That's your object loader done. Final. And as you can see, that's gone down to 10. So we've only got 10 more files to look at. Neat, huh? And our object loader is finalized. So that's everything in models done. All our model stuff is done. All our OpenGL stuff is done. All our API stuff looks okay. So there's only entities and render engines to do. Hey, this is starting to look good. And you people, I'll catch you in the next episode. So in the meantime, take care. And of course, have fun.